Hi guys, hey, in episode 4 we had a look at human interface device, HID device through USB, and now we want to see if we can get that working through Bluetooth. Now both Bluetooth and USB uses the same HID codes in order to transfer keystrokes and things through a PC. Bluetooth, of course, is got a different transport mechanism, and it is just as complex as what USB is, maybe even a little bit more. I'm not sure. It is different. It actually has an advertising mode, and it has to advertise what services it has available. And then when you go into your operating system or your smartphone or whatever, you go to USB and saying look for new devices, and it'll be shown there. Then you will connect to it and pair it and all that kind of stuff. Then once that is done, it will communicate in the 2.4 gigahertz band, I think, and it has a rotating method of choosing channels and so on, and it deals with interference, and there can be lots of devices connected to your PC and maybe other PCs as well in the same area and what have you. It all deals with all that stuff, and we are not concerned about that. That is all technical background information that is dealt with in the ESP32 microcontroller. Likewise, the actual the actual Bluetooth protocol is quite complex, and we want to avoid having to deal with that. So I've been searching for libraries and code that allows us to use Bluetooth in a very simple, concise manner. Now I have run several tests, and I have got it working all three of the microcontrollers here that we've been using. The Seed Studio XIAO S3 little board with the one USB port on it. The Chinese that you see here, the YD ESP32, it's like a DevKit C1 clone. Okay, so the idea is here to make it as easy as possible to use the Bluetooth. And as you can see in this little code over here, I'm just calling in BleKB.h. I've got one pin number 5 that I'm using as the OK button, and the only line that you need in this code in order is the task create, and it has a bunch of parameters. I haven't changed any of those. This is the way it was in the sample application that came with the code that I imported, which I'll show in a minute where it came from and all that sort of stuff. There's only one parameter there, that number 5, which over here is shown as UX priority, and it was working fine on the two larger boards, but the little XIAO board seemed to be outputting very slowly, almost like somebody was typing on the keyboard, going dit, 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 dit. And I had to change the value to 3, give it a higher priority, and then it was working fine. And I made a note on that over here. I need to investigate that in the near future. But this is really the code that makes it work. If BLE is connected, in other words, Bluetooth is connected to the actual PC or whatever, the host, and the OK button is pressed, then we go ahead. We output a little bit of information for debug purposes to the serial port to know what it's up to. We have a little buffer here. We are going to put in that buffer the uptime and the value in seconds of how long this microcontroller has been running. Then the command is actually type text, sends the characters to the host via Bluetooth, and then we make a string. The quick brown fox, the unloaded dog. We then stuff that in that buffer character array. We type that, and then we type it again using the overloaded type text that actually allows you to enter modifier keys, and we are giving it a shift key, so now it's all going to be in uppercase, whereas the first version was in mixed case, as you can see. And then because there is a character return or a new line after it, the cursor is going to be right below this line after it prints it in the beginning. So then we send key up, so it's going to be back on the line it came from, and then we hit tab. This is just for testing, so we can see the text move over if these control keys, if you like, work, or function keys, or whatever you're going to call them. And that's really there is to it from our perspective for using this software. So in order to do that, I created from the code that I downloaded from the GitHub site, and as I said, there will be links in the description. It's done by a guy called Manuel BL or something in Switzerland, and which we are grateful for. And he in turn got most of the code from embed.org. There's a comment on that in the code we'll see in a minute. And he has this sample code here, and this is what I based my code on, with changes that I made. Okay, so I took that code and I created a BleKB header file, and I put on there where I got that from, that website that we're just looking at on the GitHub is there, and put on there that I edited this thing and where it came from. It's always good to tell people that the source of these things. So the only thing that we're worried about here is defining a device name for it, because when you go to the Bluetooth and you say look for a new device, that's how it will be identified. Originally this code allowed for two keyboards, a US and a UK keyboard. I don't have a UK keyboard. I took the code out, and it's always going to be US keyboard. If you do have an international keyboard or something, when we look at the other code there, you might have to make a few changes to it. Some of that information will be in the documents that we look at. In any case, this is the header file. So there's some information in there that the system request, scroll, walk, pause, insert, home, page up, delete, end, and so on. These are the codes for these special keys. I added this tab key to it. For some reason he didn't have that in there, and I think a tab key is important to have. And there might be some other keys that I'm missing, and I'll add those. As I said, this is just a initial version that I did to test. It is working, but I'm going to be editing this and adding some comments and things to it, or what have you. I've already added some. These deoxygen comments are the ones that I added. So there's that is connected. There's the task. Send control key. So you can actually send like control C or something like that. So you just put a C in there, I guess, and then it knows it's a control key. Excuse me. Here's the type text that we used, and here's the type text that we used with the modifier keys. Now, originally, his code had this in it. And to be totally honest, I'm not a C++ programmer. I have no clue what that is and how you would use that. I've tried everything. I actually got it to compile, but it never worked. It just came back with an address there pointing to something at best. If any of you are C++ programmers and you know exactly what that is, please put it in the comments and we can share it with everyone else. But I actually uncommented this commented it out, I should say, and I created my own version, and I just passed the modified keys as bits in a uint, and that is working. But right now only the shift key, it actually, including in the original code as far as I can tell, only the shift key was supported anyway. And you can send key codes, as you can see, you saw me using in the internet main code over here. You send key code, key up tab. So this is the actual CPP file that the header file points to, and you can already see there are Bluetooth uses like reports. There's an input report and an output report. Of course, it's output from the host and input to the host, so it's output for us actually. This is the information that gets sent to the protocol through Bluetooth. You can give it some modifiers. Now, it is the definitions allow for Control, Shift, and Alt. So bit 0 is Control, bit 1 is Shift, and bit 3 is Alt or something like that. And then you can pass up to 6 keys. You can have multiple keys, and as a lot of you gamers probably know, modern keyboards allow for rollover keys. You can hit multiple keys and it will actually output them all at the same time, up to 6 at the same time, and that's what that is. But of course in our test we're only using 1 key at a time, so it's always the first entry in that little array will be used. And then there is there's a report map that gets information put in there, and I haven't looked at that too closely. This has all got to do with Bluetooth and the hid device packages and so on. It's got some callbacks, everything, and we actually and here is the there's send control key, Bluetooth task. There's all sorts of excuse me, I've got a frog in my throat here. So in any case, it has a key map. So in other words, map an ASCII value to the actual key code, and that is actually, this is the method that I commented out. It has that thing in here, and seems to have a for loop here that uses that. It's almost like it's a little array or something like that. I don't know what it is. I couldn't get it to work. So I made this one over here, and it simply says that, and I wanted to, this, what I'm working on, I'm going to make it work with the control and the alt and stuff as well, but right now it only works with the shift key. So if the shift key bit is on, then stick it in the modifier. So that one actually uses the hit keyboard types header file, and that is where, that's about as deep as you would ever have to go in order to maybe change or define some things if you got like a foreign keyboard or some extra keys you want to deal with. This actually is an enum that actually points into that two-dimensional array, if you like, over here, and the actual key code points into this array, but it is like, let me see now, for instance, here is a space, and how many lines is that? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Yeah, escape is ASCII code 27, 28, 29, 30, 31, 32. Yeah. ASCII code 32 is a space. So these are ASCII codes that are the actual how you get in here, and then you find out that the code for space is actually 2C hex, and there's no shift key involved. But for instance, a exclamation mark is 1E hex, but it has a modified key called shift, because indeed on the keyboard is a shifted character, right? So this is the entire, supposed to have the entire keyboard here. If you have additional keys, you can certainly add them. You'd have to make these key map size larger and add some extra entries and make sure that they are processed right. And it keeps going deeper and deeper. There's hit types, which has to do, you're getting closer and closer to the Bluetooth here, and I wouldn't want to deal with this. I don't think you have to. This is code that doesn't need to be changed, but as you can see, this code originally was copied from embed.org, and it has a bit license and stuff like that. So anyway, that's as far as we have to go with that. Alright, so let's have a look if I've made any errors there, if it's still compiling. Yep, success. Alright, so let's plug in our board. I'll do that off camera here. Let's have a look. COM, that's the one I want. Okay, let's plug it into my COM port on this code. Alright, and double check that it's there. Yep, COM6, that is where it's supposed to be. Now I'm going to say compile and upload. Okay, done. So now it's running, so I will go to Bluetooth, add a Bluetooth device. There it is, YD keyboard. Previously had the XIAO version already paired. Okay, device is ready to go. Done. So now I should be able to bring up good old-fashioned Notepad. There it is there. And I will push my little button over here. Well, before we do that, let's put this over here. And we will go to a serial monitor. COM6. Start monitoring. Come back here. Okay. Pushing the button. Alright. Exactly what we were expecting. And when I hit the restart button over here, you'll see it connects very quickly. Says press OK to type. Bluetooth ready, client has connected. And then this is the LED state 1, which is actually numlock. So if you are actually creating your own keyboard, some people do that. They buy switches and then they go and use a microcontroller to control their own keyboard. You would be able to turn on the LED for numlock, because it comes back with 1. No, don't save. Kill that. So that's all working. And now, how did we get there? So there is a Microsoft document, which is actually almost 24 years old, that actually tells you everything about how a Microsoft keyboard works. And it's got those PS2 Scancodes, of course, and they added some USB usage tables to it as well. So again, as I said, there will be links to these things. Goes right back to Windows 95, actually Windows 3 point something, which is the support that it has. Difference. So if you are creating a keyboard, see the numbers of the keys and everything, and they will have the scan codes there and stuff like that. So that's one thing. Here's another one of these monster documents. It has like 430 pages in it, and it deals with all the hit devices, and they keep adding new ones to it. The last entry was made in 2022, which is probably for these virtual reality stuff over here. And these medical instruments, braille, all sorts of stuff. Barcode scanners, scales, but we are interested in keyboard, which is code 7, which you'll see in that Scancode thing. See, all the code 7s over here are keyboard codes. Any of the ones that have different codes here, 01, and there are some others there, they will actually be for different pages. Then these are the codes that are assigned if you're using a HID device. So the letter A comes back with code 4, but as you saw earlier in the code, it has a modifier key. So if it is uppercase A, there would be a modifier for shift to send along with it. But if you got one of those PS2 keyboards, they have different codes. It'll come back with 1E. So that is that, where you get that from. Here's a little side subject that you guys might be interested in regarding scan codes for keyboards. In the early days, and I'm talking MS-DOS, very early Windows days and so on, in the BIOS there was a facility to intercept keyboard scan codes and to actually modify them. So in this case here, for instance, I hate the caps lock key. I never use it, and I always accidentally hit it instead of the shift key. So I actually want to take the caps lock key over here and change it to the left shift key, so it operates like a shift key. And this facility has been there, as I said, from the beginning, and as is indicating over here, I wrote this little application 20 years ago. In HKLM system current control set control keyboard layout, there is a scan code map. Looks like that, and as you can see, we are modifying code 003A to 002A, and you can kind of see that over here. There's a 00 respect to front, it's a little Indian or whatever I call it, 002A, 003A, and there's another one there, the scroll lock, I changed that to the end key because on my keyboard I got one of these little small keyboards. There's not a full keyboard, and for some reason there's a home key but not an end key, and I need an end key when I'm editing, so I could change the scroll wheel key to actually become an end key, and I put a little sticker on there so I know it's end, and you'll see that happening over here. So this has been in the right from day one in the computer systems to do that. Also, the way this little application works here, if you put the cursor over there and I hit a key, for instance, let's hit the A key, and you can see that's ASCII value 65, and the scan code is actually 001E. And you might remember from that list that we looked at the scan codes, indeed that is what the letter A has. So internally, even in Windows 11, the underlying BIOS and drivers and what have you, even though you might be connecting to a Bluetooth keyboard or a USB keyboard, it still is able to return these scan codes on this little application, and then after I make a change I can actually save it to the registry, so I don't have to edit it manually. So I thought that might be of some interest to see that we still actually, even though I am actually typing on a USB keyboard and we know that those USB HID codes are different, it still comes back when you ask the low-level API in the operating system, and you ask it to come back with a keyboard scan code, it still gives you the scan code that the original PS2 keyboards had. So what we've actually proven is that we can actually, using these live code from various sources, put it together into a library, and as I said, I'm still going to do a little bit more work on it, and we will use it in a later a whole project, and I will put that stuff on GitHub or in other places for you guys to access. The next episode we are going to actually connect a keyboard to our microcontroller, so we're going to try the host. We run the microcontroller as a host rather than as a device, the opposite of what we've been doing. I also have not found a great deal of information on that, but I believe I have that going as well, so we will investigate that. So don't forget to subscribe and to be notified when new episodes come, and in that case I will see you guys later. Bye bye.